The minimum force required to project the body of the inclined plane of inclination theta is n times the force required to prevent it from sliding down. Find the coefficient of friction between the surfaces. Means what they're saying here, the minimum force required to project the body up the inclined plane, to project it, we need some forces required. Let us say that force is F1. Now what they're saying here, that is equal to what they're saying, n times the force required to prevent, n times the force required for the body to not to slide down, and that is the F2 if I call. That means what will the relation between them is given? The force required to prevent. So if I call F1 is the force required, F1 is the force required to project the body up the plane of the inclined plane. Next, we are calling this as F2 is the force required to prevent the body from sliding. Now what the relation between them is given, tell me. The relation between these two they given. The minimum force required to project the body up the inclined plane is n times the force required to prevent it. That means what they're saying here, force required is F1. F1 is how much they are saying here? N times the force required to prevent it. F1 equal to n times of F2. Yes or no? Now from this we need to get the mu value, coefficient of friction is required. So we need to see the two cases now, for the body to project up and for the body to slide down. Two cases we need to analyze it. Right. Now let's see the first one here, case 1. Let us say the body is moving up. For the body to move up, so let's see the analysis now. Now here this is the angle some theta. Let us consider we have some block is there. The mass of this block is m. Now let us say the body moving up here. Case 1, we assume that body moving upward directions in this case. Now tell me now, if the body moves up, so we need to apply, let us say, some force we need to apply on this body. That force we are calling it as F1. Now tell me now, for a body to move up, as we know, the analysis on the inclined plane. First we need to resolve into components now. Tell me now here, resolve into components. And here this is the acceleration, downward direction. Right, here we have this as N. And we have this as, what, tell me now, mg cos theta. And this is mg sin theta. Mg sin theta. Now body moving which direction? Up or down? In this case, of which case we are considering? Up. So that means friction is what direction? So this is, friction is downward direction. Right. So now you tell me now here. So now for the body to move upward directions, so it has to overcome from the force caused by the mg sin theta and force caused by the friction. Then only the body can able to move upward directions. Now, so for a body to move up, the condition is what? Tell me now here. What is the condition? Tell me now here. So this F, yes, that is greater than or equal to, let us say, equal to, will consider. So F1 must be equal to what? Tell me now here. Mg sin theta plus F. And F is equal to frictional force now. So how much the frictional force, you tell me now? Yes, so that is equal to mg cos theta plus what, tell me now? Sorry, mg sin theta plus mu mg cos theta. This much of the force we need to apply. Then only the body will move which direction? Up the plane. Right. Now, okay. Mg cos theta. Now let us see the second case now. Now see the second case now. Case 2, the body moving down the plane. So tell me, in this case, body moving down. Is the body moving down? So tell me, in this case, what happens? See the forces. Here we have this angle is theta. Now consider we have the body, a block of mass, and this is the body. Now resolve into components first. Right. Now this is N. So here this is mg cos theta and this is mg sin theta, and body moving which direction? Down. So then how the friction? So the friction is upward direction. Now in this case, what I need to do here? We have to prevent the body motion. So that means the body tends to slide downward direction to prevent the body motion. Which direction I need to apply the force? Upward direction we need to apply the force now here. That means we need to apply certain amount of force like this we should apply now. That force is a F2. We are applying some force now so that the body can able to should not move downward directions. Right. You tell me now here. So for the body should not slide down. So that means what should be now here? Upward force and downward force has to be balanced now. That means what we can say upward forces are what we have. F plus we have this is F2. That should be equal to downward force now. That is mg cos theta. Sin theta na. Mg sin theta. So what about the frictional force you tell me now? Yes, so that means F2 equal to what? Mg sin theta minus frictional force. Frictional force we know mu n, which is equal to what? Tell me now. Mg sin theta minus mu mg cos theta. Right. Now what they're saying here? They're saying what they're saying now. See the problem what they're talking now here. So this is the minimum force required to project the body up the inclined plane is n times the force required to prevent. That means F1 is equal to n times of F2 given now. We use this relation now here. Right. Now F1 is given as what? Tell me in the problem itself. F1 which is given as n times the F2. So F1 means what you tell me now? This is mg. So we can take mg common now. Simply we'll take mg common. So mg common we have taken now. This is sin theta plus mu cos theta. And which is equal to what? Tell me now. N times na n into mg common here also. So this is sin theta. What? Tell me now. Minus mu cos theta. Now mg will get cancelled. And here we need to get the mu value we have to get. So get the mu value now here. So this is sin theta plus mu cos theta equal to, tell me now here, n into sin theta minus mu n into cos theta. All sines one side, cos one other side if we bring now. So we'll come it as what? Tell me now. This is mu cos theta plus mu n into cos theta, which is equal to n sin theta minus sin theta. Then we have taken the cos common here, mu cos common. Mu into cos theta common here. Then it is 1 plus n. 1 plus n equal to sin theta common here also, which is equal to n minus 1. So we need to get the mu value, right? So mu is equal to, this is what? Tell me now, n minus 1 by n plus 1 into sin by cos, which will be a tan theta. So this is the coefficient of friction in this case.